All right, in this lesson, we're going to talk about roots and radical expressions. To start off, let's get a general understanding of what we'll talk about. First, we're looking for real solutions, so there'll be no imaginary numbers in this lesson. For a real even root, the radicand, what's inside the radical, has to be a positive number. If it was a negative number, you would then have an imaginary solution. So for any even root, such as the square root, the fourth root, the sixth root, inside has to be positive. And when you get your solution, you will have both the positive and negative answer. Right? For example, if I take the square root of 16, I know that that's both a positive 4 and a negative 4. Nope, not 2, negative 4. Right? And we've also written that as plus or minus 4, such as I did over here. And that works for anything, any even value. If I had the fourth root of 16, that's going to give me both the positive and negative 2. So any even root, you'll have two answers, positive and negative. If you have an odd root, such as the cube root or the fifth root, right, if your radicand is positive, right, and again, that's what's underneath the radical, we're talking about an odd root. If your radicand is positive, then your answer is also positive. For example, if I want to deal with the cube root of 8, my answer is just positive 2. Positive radicand, positive answer. If you have a negative radicand, and again, we're talking about odd roots, then you're going to have a negative answer. For example, if I take the cube root of negative 8, my solution would be negative 2. And to show you that in reverse, if I take negative 2 3 times, negative 2 times negative 2 is positive 4, times negative 2 gives me negative 8. All right, so let's see how this plays out in our problems. Our first example is find all the real square roots for each number. I see that this is a positive, so yes, there is a real solution. I simply want the square root of 400. You can just go to your calculator. Here's second square root, 400. All right, the calculator only tells you the primary solution, which is the positive number. But we know that with a positive, or with a even root, you have both positive and negative for your solution. So plus or minus 20. Number 2, the square root of negative 196. Well, this is a negative number. I'm talking about an even root. There is no real solution. It is imaginary. And that was in a previous lesson. This time we just are looking for the real solutions. Okay, I look here. It doesn't matter if it's a whole number or a decimal. You still simply take the square root of 0.0625. Again, you can just type it into your calculator. 0.0625. And you get 0.25. As long as you come up with a positive number, then you know you have to include a negative. The next set asks you to find the real cube root of each number. So again, we can just go to our calculator for this. 216. I'm looking for the cube root. I know it's a positive number, so my solution will be positive. Cube roots, you go to the math. Right here, it's number 4 and 216. I get that it's 6. In a further lesson or a later lesson, I'll show you, going back to our factor tree, how to solve this. Right, so go ahead and do number 5, negative 343. Push pause and then check your answer. I got that it was negative 7. It's a negative on the inside, so I know my answer has to also be negative. Right, the last one I want to go over on a cube root is what do you do when it's a fraction? We're simply going to take the cube root of each number. So find the cube root of 1,000, and as separate, find the cube root of 27. The cube root of 1,000 is 10, and the cube root of 27 is 3. So 10/3 is your answer. Going on to our next set, we want to find the fourth roots. We're going to do it the same way. I just want to show it to you on your calculator. Fourth root means it's an even, or even root. So if I look at number 7, the fourth root of negative 81 is not going to be a real solution. It's imaginary. So I simply write no real solution. Okay, don't forget that rule. Number 8, the fourth root of 256. Right, whenever you write roots, you just kind of put the 4 right there inside the little neck of the radical. On your calculator, go to math, or wait, hit 4 first, because you're talking about the fourth root. We go to math. And right here on number 5, you'll see the little x radical. That lets you take it to any root. So this tells me it's the fourth root of 256. Enter, and I get the answer is 4. And it's a positive, it's an even root, so I know it's both positive and negative 4. Okay, go ahead and try number 9, push pause, and then check your answer. All right, after typing it into your calculator, you should get 0.1, so we know that it's plus or minus 0.1. Okay, and that's the basics on finding your different roots in the calculator. The next thing I want to talk about is when we're looking for variables and we're trying to take the fourth root or the fifth root concerning variables. So in previous lessons, we've dealt with square roots. On square roots, we looked for pairs, or you grouped, looked for groups of 2, circled them, and pulled them out. If you have cube root, you're going to look for groups of 3. If you find 3 x's, you'll circle and pull it outside of the radical. Fourth root, you'll look for groups of 4. Fifth root, groups of 5. Sixth group, groups of 6, things like that. Okay. All right, we want to simplify each radical expression, and we'll assume all variables are positive. So you don't have to worry about it being an even root, was the x a positive number or negative, making it real or not real. We'll assume everything's positive. Okay, we're going to look at the numbers and the variable. Square root of 81, if it's something you know right away, square root of 81 is 9. You can simplify without doing a factor tree. If you're looking for the square root of x to the 4th, remember we're going to look for groups of 2. So I take my x to the 4th and put it in groups of 2. There's 2. 2 more makes it 4. There's one group of 2, 2 groups of 2, So I pull out two groups, making it x squared. My solution is 9x squared. All right, let's try number 11. We're talking about the fifth root of something. Okay, if you don't know right off the bat what the fifth root of the number is, you can always go through and do the factor tree. This is what my factor tree would look like. If I didn't have a calculator or I didn't know the fifth root of 243, I have 1, 2, 3, 4, 5. So there's one group of 5 that I can pull out of the radical. So I'm dealing with my number. Now let's look at the x. X to the fifth. That is one group of 5 that I'm going to pull out of the radical. And now look at the y. Y to the 15th. How many groups of 5 are there? If you can't see it right away, you can write out the y's. 1, 2, 3, 4, 5. There's one group. 6, 7, 8, 9, 10. There's two groups. 11, 12, 13, 14, 15. 1, 2, 3 groups of y. Or take 15 divided by the root, which is 5, and I get 3. My solution is 3x y cubed. All right, you go ahead and try number 12. Push pause and then check your answer. All right, there's my solution. I factor treed the 8 into 2. I had a group of 3. I pulled it out. I went ahead and wrote out 6 g's and grouped them by 3's because my root was a 3. I had two separate groups of 3, so that's where the squared came from, leaving my answer as 2g squared. All right, our last type of problem is finding real solutions for each equation. In the first one, x squared equals 4. To get rid of a square, I do the opposite, which is a square root. And if you square root one side, you square root both sides. So x is equal to 2 and negative 2, because again, this was a positive root. Okay, I have x to the 4th is 81. To get rid of a 4th, I'm going to take the 4th root on both sides. Okay. Using my calculator, I find that the 4th root of 81 is 3. It's an even root, so I know it's both positive and negative. All right, go ahead and do number 15. To square root, just remember, do the top and the bottom separate. Push pause and check your answer. All right, there's my work, and I got plus or minus 4 over 7. All right, in our last problem, we're going to use a geometry formula given here, and it asks for the radius, they want to know r, of a sphere with a volume, so v is 36 pi cubic inches. So I'm going to plug in 36 pi for the volume, 4/3 pi r cubed. Okay, when you've got the same variable or same number on both sides of your equation, they cancel each other out. To get rid of a fraction, I'm going to multiply by the reciprocal. I get 27 equals radius cube, and to get rid of a cube, I'm going to take the cube root. Right, the cube root of 27 is 3, and since it's a positive number and an odd root, all I have is the positive 3 inches equals the radius. All right, the last problem, number 17, I'm going to have you guys try on your own. Push pause and then check your answer. And my solution is given.